Yes, sir.
Yes, sir, it's
Okay.
visible.
So we in the last class, I think we have started this chapter,
Yes, sir. We have
fluid
done the
state.
hydrostatic law.
Yes. And so far in this, we have completed the basic concepts of the fluid statics, and also we have discussed the Pascal's law in the last lecture. Uh, that okay, we have also discussed the different the pressure means the different form, you can say the different unit of the pressure like absolute gas, vacuum, and atmospheric. So all these different type of pressure we have discussed the last class, and then we have seen how the pressure head comes into the picture and what is the relation means the mathematical expression for the pressure head. And yes, we have completed this hydrostatic law, and I think we have stopped after completing this hydrostatic law. Okay. And also we have discussed this atmospheric means the different units, you can say the different unit of this atmospheric pressure, because atmospheric pressure is measured in all the different units. Okay, in all the different units. So any unit can give you the atmospheric value. There's atmospheric pressure value. Okay. Now, after this, let me continue this chapter, this fluid statics. Now, the measurement of atmospheric pressure means how the atmospheric pressure measured. So, there are some instrument with the help of that we measured this our atmospheric pressure. So, like barometer. So, barometer is a device to measure the atmospheric pressure at any point on the earth. Okay, so this is a simple mercury. You can say the mercury barometer. As you can see here, we have this that is 76 mm of Hg. So that will give you means that height. If you will use this is your height means that is 76 mm. Hg of height will rise in the tube. Okay, and that will give you the atmospheric pressure. If it is mercury, if it is like mercury, if you are using water, so it will goes like 10 meter, or in the feet it will goes like 33.9 like this. Okay, so this amount of pressure you will feel. So these are the some instrument which is used for the measuring of this pressure, like liquid barometer. So this is your liquid barometer, and this is anaeroid barometer. Okay, but it measures the atmosphere by the action of an elastic lead of evacuated box. Okay, but means the principle of this anaeroid barometer is based on basically not on the fluid system. You can say this is the fluid system. Okay, means the pressure measurement technique or the principle is based on the fluid mechanics for this liquid barometer. But this anaeroid barometer is totally based on the mechanical concepts actually. Okay, mechanical, like the spring system like this. So this is not covered. That's why this is not covered actually in the syllabus. Anaeroid that discuss in the, you will find the anaeroid actually in the fluid mechanics book, but not discussed in the means in the syllabus, because this is based on the like the spring constant and all these concepts. Okay. But yes, this is our concern. Like means this liquid manometer is our concern, because here we use the concepts of the. So let's discuss this liquid barometer some more with more explanation. So it consists of a transparent tube like this. This is our transparent tube. Okay, this one is our transparent tube which is open at one end. Means that end is opened actually, and then this tube is filled with like the liquid and inserted into a jar. Means like this here. Okay, here you can see that there is some another fluid, means like air. You can say all means air already present in the atmosphere. So that part is filled with air, and this is the jar where we generally consider like the like mercury or water, you can say. But yes, for water you have to maintain a very large length of the tube, like 10.3 meter. Okay, so that's why we use the mercury, because the specific weight means this of this mercury is 13.6. So means the specific weight of this mercury is 13.6 times higher, 6 times higher than H2. So that's why we use mercury so that it can balance the more pressure with a very limited rise in the height. Okay, so that we can use the compact device. If it is a water, then it will give you the it will require very large tube. Okay, so the liquid initially drops in the tube due to the gravity, but it stabilizes at certain level under the atmosphere. So this is our certain level, means this will decide what is the pressure outside it. Mean outside means, or you can say the your atom, yeah, the pressure in the atmosphere. Okay, so this is our height. You can say this is the height. Okay, so this phenomenon occur there. So here you can see what are the forces acting. It is like the atmospheric pressure. This is your pressure which is exerted by the air, means the atmosphere. Okay, so this when this pressure will exert, so what will happen? There is a rise, means result of this pressure is the rise of this liquid in the tube. So, and here, yes, obviously, initially there will be some air here. So it is called like the vacuum, because here the pressure will be exerted by the different fluid. So here you can say that there is some vacuum pressure also, because fluid will goes up to this and some part will be left here, which will act like a vacuum inside this. Okay. So this part is means there is some vacuum force also, and yes, there is a weight, because that amount will have some weight, that this amount. Okay, so weight will also act there. So these are the three forces which generally act in the barometer. Okay, so generally mercury is preferred, as I told you, because because vapor pressure is minimum. So if vapor pressure is minimum, so it will not like boil easily, like as I told you. Okay, so moreover, its specific gravity is high. As I told you that a specific gravity means like this, your Rosy value, the specific weight. A specific gravity means this, like this is your water, this is your mercury. So that value is like 13.6 times. So that's why it will balance the more pressure with a minimum or minimum rise in the height. Okay. So that's why we use generally mercury, or I think in the thermometer, the concept is same. Why we use the mercury with some other concepts like the thermal coefficient of expansion of the mercury is also large. So that's why it is also considered in the thermometer. And here in the for the measuring the pressure also we consider because of this. So barometer using mercury is called mercury barometer, while using water is called the water barometer. So size of barometer tube, that here we need to be very careful that the size should be more than like 1/2 inch, means the half inch, so that the capillary action will be avoided. So what happens if you will take a very fine bore? So due to this capillary, the fluid will rise. So this will not give you the correct reading of the pressure, because there will be some action of capillary, so that we have to check that the diameter should be greater than that amount, which will not produce the capillary action. So mostly it is considered like 13 to 15 like this. Okay, in this range your capillary action will not work. So these are the some concepts or the idea of this liquid barometer, how the liquid barometer works. Okay. After this, the most used instrument for measuring the pressure, okay, we will discuss here. What we have discussed in initially, it was the barometer. So barometer is used for measure the atmospheric pressure. Okay, so means only the atmospheric pressure. But what here we are going to start this, it is the devices which is generally used to measure pressure in the system. Means the system which is based on the fluid flow, the fluid mechanics, like water flowing through the pipe. So what is the pressure inside the pipe? Like this. Okay. So these are the instrument which is used for measuring the pressure in your fluid system. What are that instrument? It is called the first, the very simple, very old, the first, you can say the very first device for this class. Okay, means I will discuss elaborately what is that class actually. Is the piezometer, the very conventional method. Then comes some advancement, okay, in this piezometer, and their name is changed to manometer. The concept is like the same in this, but there is some advancement in the some you can say the upgradation of this piezometer, and the name change into like the manometer. We will discuss, and then like these are the some mechanical. Again, I like here there was a different here anaeroid barometer. Same thing is here. We have some devices which measure the pressure based on the mechanical systems, like the springs. Like I have given you the example that at your airfield station, airfield means airfield for the bike and means the two-wheeler and the four-wheeler. Okay, actually this is used mechanical pressure transducer and electrical pressure transducer. Here actually for this airfield system, we what a Borden gauge is, they use this Borden gauge. So what they use for the measuring of the pressure inside your tire is the Borden gauge. Okay, that the name of that device is the Borden gauge. Okay, and their unit is also PSI. So when you will visit the airfield station, the unit in which this Borden gauge measure is the PSI, pound force per square inch, like this. Okay, so these are the based on the mechanical and electrical, not the fluid. They are not based not a fluid based system, not a fluid based system. Okay, they based on the mechanical systems and the electrical systems, because means there are some other means by which we can measure the pressure. But yes, these two is our concern, which is based on the fluid concepts. This is based on the fluid concepts. You can write based on the fluid concepts. Okay, so this is our concern in this fluid mechanics. So now let me discuss the first this the piezometer, means the very conventional piezometer. The very conventional piezometer is the shape of this piezometer is like this. Let me draw a piezometer here. This is our example of this piezometer. So let us suppose there is some liquid inside this container. Okay, so obviously if there is some liquid inside this container, so it will exert pressure, because due to this height, obviously we will have some like P is equal to P rho G H, and due to this pressure there will be some rise in the liquid height in this tube. Okay, so this may rise up to H. So the rise in the H, this rise in the H is depend on the pressure inside the container. Like at this level, the pressure will be different. At this level, the pressure will be different. At this level, pressure will be different. Okay, and the reading of the piezometer is the gauge pressure. Why gauge pressure? Who will answer? Anyone? Am I audible? Anyone
Yes,
is
sir.
there who can answer why
Yes, sir.
it is gauge pressure? Who will answer? Please.
Sir,
Because
weight of
because
Sir,
liquid is
because
also
it
there.
is measuring.
Because it is against atmospheric pressure. Because fluid will rise along against the atmospheric pressure, means there will be atmospheric pressure also. So that's why it is, because air will rise this, because the one end of this tube is open-ended. So when it is open-ended, so it means there will be some atmospheric pressure inside this tube, and the fluid will rise against this atmospheric pressure. So obviously it will add the atmospheric pressure. So that's why it gives you the gauge pressure reading. Okay, wherever you will find that there is a atmospheric pressure, so you can easily answer, okay, there will be gauge pressure. Okay, because now you have the idea of the all these gauge, absolute and atmospheric. Okay, so this is the very simple, you can say the very simple, very conventional, a very first type of manometer, you can say. Okay, the name is piezometer. This is very conventional. It is not useful for measuring a very high uh, pressure. Okay, it is just for a very small pressure. We use piezometer for a very small pressure. Okay, so all the things here is written is the same as we have discussed here. You can go with the. Okay, so yes, the diameter we have to check again. The diameter should be greater than half. I have already discussed why it should be greater than half inch. Okay, and it must be used only for the liquid. Yes, it must be only because like the it is not used for the like gas. Okay, it is not useful for the gas. If you will release this, if you will release the gas through this open inlet, all the gas will escape through from the container. So it is not used for the gas. It is only used for the liquid. And it should not be used for high, as I told you that, okay, here it is written. It is not used for the high pressure. It is only preferred for the low pressure, okay? Because it's very simple. And it cannot measure, yes, it cannot measure the vacuum pressure. That is the important point because it always works against the atmospheric one because one end is open ended. This end is open ended. So it will not give you the vacuum pressure. So this is our piezometer. Okay. If you will go through any book, you will find this structure of the piezometer. Now then comes the another as we have seen here that after the piezometer. Hello.
हेलो सर
Yes.
सर पीजोमीटर में जो लास्ट पॉइंट एक लिखा था सर ऊपर वाला जो फोर्थ पॉइंट है ऊपर से
Piezometer may be connected to sides or bottom of the pipe to avoid eddies.
सर एडीज क्या होते हैं
अभी आपको एडीज मैं नहीं बताऊंगा बट आई विल डिस्कस इन द डायनेमिक्स चैप्टर ओके ओके लेट आई विल गिव यू सम okay just a short description like this okay? Like this
ओके सर
so what happens here this is a pipe system let us consider that this is D and this is D okay this is a small d. This is a small d and d is greater than d. So what happens when fluid will come here? It will suddenly find there is just some change in the diameter. Okay. So in this area, in particularly in this area, I will find some eddies like this. So eddies is like this. It will start like this moving due to this obstacle. Fluid will come. Okay. And sudden change in the diameter will generate some eddies. So that happens actually with this because what is this you can say the width of the container it is like very large in comparison to this so suddenly what happens when fluid comes here so some aid is generated here so when aid is generated here it gives it may give some wrong reading so sometimes what happens we use a bail mouth this is called the bail mouth okay bail mouth means like here like what actually we try to develop like this so that this type of eddies will be avoided here because look at here this is a gradual change but this is what this is a sudden change this is called the sudden change so and this is also called the bail mouth okay so generally you will find when such type of system is there so we use this type of the gradual change in the shape if there is a sudden change it will cause some eddy generation and eddy generation gives some like the pressure drop or some other effects there okay so this is the eddies
okay sir
okay so now let's discuss this the manometer okay an elevation change of delta in a fluid at rest correspond to change in this del P by Roger. Obviously, we have the expression. We can easily understand this. Okay, that we have already derived this equation from the hydrostatic law. So obviously, if there is a change in this, okay, means if let me write down this in the form of this. So this is actually this. Okay, so whenever there will be change in the del Z is what? That is our elevation, like this. 0.1 and this is 0.2. So this is our del Z. Obviously, if you move these two here, so we are changing this del Z. So obviously that will change. So basically the pressure change because these two are the constant if you are dealing with the same fluid. Density and G will be constant. So basically there is a change in this pressure. So due to change in the elevation, there is a change in the pressure, and ultimately there is a change in the head. This is actually head. This is called the head. This is called the head. Del P by rho g is called the, this is called the head, and for the, in the case of pressure it is called pressure head. That will come in the future lectures in the dynamics. Okay, that pressure head. So this is actually called the pressure head. This is also energy. This is also energy. Energy in the unit of meter. Energy in the unit of meter. Okay. Why meter? Because you can see here these two are the constant. Rho g is constant. So and pressure is actually what? Force. Okay. So this is also like a unit of energy, because these two constants, so we can easily divide by rho g. Because in a system, if you are dealing with a particular fluid, so in that system, your raw density and g will be fixed. So that's why it is also denoted in the terms of head. The unit of this head will be meter, because it is height. Okay. So this is sometimes called head. Maybe it will be mentioned somewhere in here. Okay. So this will change. So we suggest that a fluid column can be used to measure the pressure difference. Means according to this hydrostatic law, if you are maintaining this, so we can come out with the answer of this pressure. So that concept is utilized in the manometer. Means if someone asks what is the principle of the manometer, so it is the hydrostatic law is the principle of behind the manometer, over which that device. So a device based on this principle, okay, it is written here, is called a manometer, and it is commonly used to measure like a small to moderate. So that actually piezometer is used for a small, and manometer is like from a small to moderate type. Okay, not a very high pressure. It is used for the moderate type. And manometer mainly consists of a glass U-tube that we will. Okay, let me show you the picture. It is better to discuss with the picture. Okay. This is basically, this is figure is manometer. So you can see here, what is the difference from the piezometer and the manometer? What was the diagram? I mean, means the shape of the piezometer. It is like this. This is your piezometer. This is your piezometer, and this is your manometer. Okay. Now you can see here the concept is like the same. Look at here. If you want to measure the pressure at this point, so you have to add this U tube. What will happen when we will add this? So due to the pressure inside this container, obviously there will be some pressure inside this container. Your liquid will start rise. And here in the manometer, actually we use a heavy liquid like mercury. Now, I think there is no need to say why we use mercury, because mercury is heavy. It can balance the more pressure. And this is the concepts of the manometer. So it consists of a U-tube. Okay, this is our U-tube. You can see here, this is U in this shape, part of which is filled with manometric fluid. So this fluid, which is heavier sometimes, okay, and sometimes it is lighter also, but that totally depends on the application. But generally, if you have some high pressure, then obviously we need to use a heavier fluid like the mercury. Means when means the specific gravity, okay, of this mercury, means this manometric fluid. This is not specific that here it should be mercury. That's why it is called manometric fluid. That fluid can be anything whose specific gravity should be larger than this fluid, which is inside the container. That we have to check. Okay. See what fluid is inside the container, what fluid is inside the tube, whether the specific gravity of this is greater than this container or not. And accordingly, the phenomenon will occur, because you have the idea now. Okay. So one end is again in this case U-tube manometer, one end is connected with the pipe whose pressure is required to be determined, like here. Okay, and one end is open-ended. Due to pressure level, manometric fluid rises on one side while falls on the other side. Means due to the pressure, what happens? This liquid which is inside the container, will try to push this manometric fluid. Okay. And at the equilibrium, what will happen after some displacement? Both the fluid will balance the pressure, and then this is the time when you need to take the reading of the pressure. Okay, so difference in level is measured to estimate the pressure, like here. So again, I told you that there is an atmospheric pressure also, so we have to add this. So pressure at this point, what is the rise in this limb, will give you the pressure at this point. Okay, so this is how you can measure your pressure with the help of this manometer. Okay, now with the same concepts, like here, this is your simple manometer. Okay, we have another type which is called the differential manometer. Okay, so simple manometer is used for measuring the pressure at a point. Simple manometer means the pressure at a point. And then what is the meaning of this differential? So as the name suggests, differential means difference. And obviously when this word comes into the picture, difference, we required 2 points, because we have to calculate the difference. So when you will able to calculate difference, when you have the two comparable things. Here in our case, it is like the point, the location. So we require the two location, or you can say the two elevation, or the two pipes. That can be anything. Mean the either 2 points, okay, or two different pipes. Means what is the pressure difference between the two pipes also is measured with the help of this differential manometer. Okay. So this gives in the pressure. So differential fluid column of height h in the static equilibrium, and it is open to the atmosphere. Then the pressure at 2.2 is determined directly with this. Furthermore, since pressure in the fluid does not vary in the horizontal direction, yes, obviously, so pressure at this point and at this point will be same, because they are at the same horizontal line. And with the same horizontal line, the pressure at this and this will be same. So this will give you the pressure, like means what is the pressure at point here, it will be here. So in this way, you can calculate the pressure. Now, differential manometer, as I did give you the some brief information. So for calculating the differential manometer, we require the two different points or two different pipe. Means if this is our manometer, which is connected at the two different points. Obviously, what happens? It is the pressure difference which governs the flow. Means at point 1 and at point 2, there will be some pressure difference. If there will be no pressure difference, then flow will not occur. We know. If the pressure is same, okay, in a horizontal pipe, then there will be no flow, because we have to include some driving force, means unbalanced force. If there is a balanced force, then it will be in equilibrium. So flow is only possible when there is some unbalanced force. So obviously, at the two different points, there is some difference in the pressure. And now you are willing to find out this pressure difference. What is the difference between the pressure at this point and this point? For this, we use the manometer. So what happens here in this simple manometer, the one end was open. Okay, so instead of leaving one end open, it is connected to the other end. Obviously, there is a 2 points having the different pressure. So obviously they will push the fluid inside this manometer with two different height, because the pressure is different. So what we need to do, we need to calculate this pressure difference, that is like P1 minus P2. What is the expression? Okay, so this is your manometer. So if you will go with this, you will find the same statements or the text which I have told you. Okay. Yes, one more thing again here, because we have already discussed that there is some manometric fluid. Okay, means when that sometimes it may be a small, or maybe it is higher than this density. Okay, as I already mentioned. So working fluid can be either a gas. Here it can be gas. Yes. Manometer, this is the difference. In the simple manometer or piezometer, we cannot measure the gas because it is open at one end. But here it is not open, it is completely closed, so gas will not escape. So obviously we can use the differential manometer for the gas medium also. Okay, so density of the manometric fluid is ρ2, and this is the density of the either gas or liquid, you can take anything. Okay. Now this is our manometer. Okay, now let us generate the expression for the P1 minus P2. This is the expression. So let us discuss how this expression will come into the picture. Okay, so here there will be some pressure. Obviously, that pressure is P1. Look at here. Plus, what is the pressure on this left limb? This is called the limb. Okay, that is limb. So this side is left limb. This is your left limb, and this is called the right limb. Okay, so in the left limb, obviously we have a pressure P2 plus, look at here, the height of this means you can say the pink color, which has density ρ1. It can be either gas or liquid. Okay, so look at this, that is A H, because this is the height. So A plus H, so that is A plus H, and then means we are using this relation. Simply we are using this relation. So at the place of density it is ρ1, at the place of H it is A plus H, because the height is A plus H. So look at it. So the total pressure on this side is P1 plus ρ1 G into A plus H. Now move to the second side, means this is for the A plus H into Z. Now that will be balanced by the other side, means the right limb, obviously. Now what is the height of this fluid here? It is, okay, first of all here we will have some pressure, that is P2. And then there is a rise of this liquid, that is A plus, so that is P2 plus A into, okay, density of this liquid is ρ1. Look at here, it is ρ1. So we have to multiply with ρ1 plus, sorry, G. And then there is some fluid, means the manometric fluid is also there up to height H. So we have to add this also, that is H into ρ2. What is the density of this? It is ρ2, so that we have to write, and then G. Okay, so look at here now. When we'll do this, actually this equation is same. Okay, when you will move this here on this side, it will give you the same result. So now look at here, after some simplification, that is P1 minus P2, you will come out with this expression. Because if you carefully look at this term and this rho A Z will cancel, means this will be cancelled. And then you will have only the H term. Look at here, that is ρ1 and that is ρ2. So look at here, that is ρ2 minus ρ1, the only H term there. So this will give you, this expression can give you the difference in the pressure at the 2 point. Any doubt?
No, sir.
No, sir.
Should we can we move further?
Yes, sir.
Okay, now
Sir.
then there are some other manometers also here with some upgradation. Upgradation means the idea how to increase the means the you can say the means the how we can increase the pressure range, means the pressure measurement range. Like here, as I told you, just a minute, students. I'm getting an important call actually. Okay, so there are some other manometer is also here. What happen? What is the difference? That there is some reservoir here. Okay, the concept is same. Means like which we have discussed here. Like these are the. It is actually your piezometer manometer is based on the balancing of the liquid. It all our work on these concepts, balancing of liquid in one column or in two column. Okay, like one limb or two limb. The concepts, the basic concept is same. What happens? There is some slight changes in the geometry. Like here, we have added a large reservoir. Okay. Now, what is the idea behind adding this large reservoir? The question is this. The rest are the same. And the mathematical part is same. There is a very little change. So the idea behind this reserve, adding this, if you are changing here a very large pressure, due to this large pressure here inside, there will be a very small increment. Like here you can see the del H. And due to this small increment, there is a small increment in the del H here in this limb. So what happens? We are actually trying to measuring the high pressure with a little rise in the height, so that we can decrease the length of this manometer. Means you can say the tube, the limb. Okay, because the main complexity in this manometer is the height of this limb. If you have a very large pressure, then your manometer should be large because your liquid will rise up to a good height. But if you are adding a large reservoir, so it will respond very slow because their space, their area is very large. Okay, so to give a very large increment, that the pressure should be very large because this reservoir, the large reservoir, will contain the more liquid. And due to this, there is a very small change. So this is how we are upgrading this manometer to measure some high pressure. The main idea, and the rest are the same, like the balancing of this fluid, and this fluid will give you the pressure. The same concept. Similarly, we have another which is called the inclined. Means here we are some inclining this. So what happens? Look at here H2. So at the place of direct here, the vertical rise, we have some inclination. So you can understand that with this inclination, your pressure measuring capacity can increase up to some amount by doing these tasks. Okay, so this is some another examples. Here also comes another manometer which is called the inverted U2. That is inverted U2. This is for the means inverted differential manometer, and it is connected like this between the two pipes. This is the two pipes, pipe 1, okay, and this is pipe 2. So this, look at here, this is inverted. So this is called inverted. Concept is same again. There will be some rise in this, but the difference is what? This rise is against gravity. This is against gravity. So at the place of positive, there will be some negative terms. That's the only. But again, that the concept is balancing of liquid because this rise will against the gravity. So further it will give you some more reading like this. So these are the some other manometer. Okay, the concept is same, but designing is some design. There is a difference in the slide designing parameters. Okay, that's the only. So this is your inclined single column manometer. These are this is your single column manometer. This is inclined single column manometer. This is inverted U2 differential manometer like this. But the overall concept is same. So we have some advantages and disadvantages, okay, of this manometer basically. As I told you, the limitation like means the usually obviously it is like the bulky, okay, and very large like tube length. So large, it is large, and yes, the one of the demerit of this manometer because it contains tube, okay, tube there. So there is a more chance to be broken. Okay, so this is one of the limitation that manometer broke easily actually. And the reading of manometer gets affected by temperature and altitude and gravity. Yes, if there is some if you go with height, okay, like this, so as altitude is changing, and with the altitude, we know that the pressure changes. So, like if you are doing the talks in the like the in the air space, you can say with this manometer, so that maybe it will fail because due to change in the altitude and the gravity. So that means the reading may be affected. You will not get the correct reading types. Okay. So these are the some, and also if you have a very high temperature fluid, so what happens due to the high temperature, that there is a chance of the change of this density. Okay, because density changes with temperature. This changes with temperature. So with like means if you have a very high temperature means the temperature which can change the density. Like so for a very such type of system, a manometer can give you some wrong reading. Okay, capillary action is created. Yes, because it is also a tube. So if you are not using perfectly, okay, the diameter, so there may be a chance of this also. The reading will include the capillary action, okay, because we know that this tube is also a fine tube. Okay. So there is a chance. It is called that there is a chance of this. Meniscus has to be. Oh yes, actually, what happens when the reading will come in the tube? Look at this tube. Let us suppose this is a tube. So we have to take the reading. So what happens? We know that all the liquid makes a meniscus like this. So you will be confused at which reading we need to consider, this one or this one, like this. So and that meniscus, like here we have to take this. So in this case there is some confusion. Okay. And also if there is a like suppose you have a system, this is your system. If this is your system and it is connected with this, and that system has some, let us suppose that system has some motor. Okay, it is not written here. This limitation is not written here, but what I have found practically that I am sharing with you. If there is a motor, so obviously there will be some vibration. So what happens due to this vibration, that the liquid height here changes like this. It fluctuates. So you will not be able to take the correct reading, sir, whether I will take this or this like this. So we need to consider like the average. So there is still some confusion like this. So these are the some limitations. But the yes advantage that it is easy to fabricate. You can prepare at your own actually. You can make at your own. It is so easy. Less expensive because it contains only the tube. Good accuracy here I am not satisfied, but it is written like the good accuracy. Good accuracy in the sense like means this such type of like the vibration will not there, capillary action will not there. Then you can say that yes, it is good accuracy. But if these things are included, then accuracy may fail. Okay, high sense, yes. So small changes is counted in the tube. So it is sensitive. Yes. Require little maintenance because it is very easy. And like here, it is not affected by vibration. If it is not affected by vibration in the case, here you need to mention that it is if it is not connected with the system directly. But direct the case of direct, sometimes I have seen that it fluctuates like this. In fact, in our lab, I have seen that it fluctuates many times. Okay, so that may be some. Here you need to be careful that when it is not affected. Okay. Especially suitable for low pressure and low. Yes, that is we have already because low to moderate. High for high pressure manometer is not used. Then we goes for the like the modern gears means for the mechanical and electrical system. Okay. And easy to change sensitivity by changing the manometric. Yes, if you will change the manometric fluid, sensitivity will change because if you will change the density, obviously if you are using more heavier, it will sense less. If you are using the less heavier, the sensitivity may. So sensitivity can be easily controlled by changing the manometer. Okay. So these are some your limitation and the merit of the manometer. Now we have the pressure transducer. As I told you that there is a mechanical system also. This is our mechanical system. This is our Baden gauge actually. Okay, so transducer is a device used to transfer energy from one system to another. So mechanical pressure transducer converts pressure system to a displacement in a mechanical measuring system. So that actually transducer, what happens? The concepts of this gauge, Borden gauge is transducer. Transducer transfer one energy to the another form, and then from that form to like the spring energy, and then this spring energy gives you the reading. So this is means the overall or the broad idea of this burden gauge, how it works. Okay. But as I told you that yes, this is not the like the part of the fluid mechanics. It is like the spring system, the mechanical system. Okay, so it covers in some other chapters like the measurement technique like this. So, but yes, this is the we have the idea of the burden, how the burden goes works. There's just some spring system you can see here. So one form of energy is transferred into like the spring energy you can say, and that spring energy gives it the reading like this. Okay. So if that is used, this device is used for the high pressure, and also there is a provision to give you the reading of the negative pressure also. Means that there this arrow can goes down to that atmospheric pressure also. If there is a vacuum, so that can also be measured by this modern gauge. Okay, so this is your burden gauge, and this is used for the vacuum pressure and for the gas pressure both. This can give you the positive and negative reading both. Now here I will stop actually today because now the next we have the next topic actually, that is force on the immersed body. This topic is totally different actually, and that I will start from the next lecture. Okay. Here I will stop. If you have any question, then you can ask.
Sir,
Yes.
sir, we can use gas in simple manometer also.
No, manometer is not big. It is open-ended estimates. Okay.
Simple one.
Differential you can use.
Okay, sir.
Okay. I have already mentioned this. For the gas, manometer is not used. Differential manometer because it is closely packed. Okay.
Yes, sir.
For the gas system, actually, again, then we use this button gauge, actually, mechanical system.
Okay, sir.
Okay, now I will take the attendance. Avhilesh is present. Abhishek Zangir. Abhishek Kumar third is present. Abhishek fourth is absent. Adarsh